Hello, my name is Sankar. Today I'm going to explain you how to conduct the shear box test on a given sand sample. The objective of the shear box test is to determine the ultimate shear strength of the given sample. So we use the ultimate shear strength in order to determine the failure surface and the strength of a soil sample given. When you construct something on a built-up area like that, this portion of the sand or the soil can fail, and the shear strength of the particular soil sample or the sand sample will have a resistance built up which keeps this wedge of soil here. So our objective is to find out what that shear strength is. In our practical, we are going to use two types of samples. One is a loose sand sample and the other one is a dense sand sample. Each sand sample will be subjected to three different normal loads, and when you plot the horizontal displacement versus the shear strength curves for both the samples, you should get loose sand sample going up like this and asymptotes here, and the dense sand sample, the shear strength goes up and comes down a little and asymptotes again to the same value. The equipment to conduct the shear box test is the shear box itself, a vernier caliper to measure the dimensions of the shear box, and a metal scraper, a tamper, a hammer, the shear box testing apparatus, and obviously the sand sample. First, measure the weight of the shear box with the cap in it. So place it inside and measure the weight. That's 3.308 kilograms. Now, using the vernier caliper, we are going to measure the internal dimensions of the shear box. You are going to use those values to determine the density of each soil sample. First, I'll show you how to prepare a loose sand sample. Using the spoon given, gently pour the sand inside the shear box. Make sure not to shake the shear box, otherwise it will compact the sample and give you a little denser sand sample. Now scrape off the excess sand from the top of the sample using the steel edge. And place the cap on top of the sand sample. Make sure these grooves are in the perpendicular direction to the arm of the shear box. So once the loose sand sample is prepared, you measure the weight of the soil sample using the scale. You hold the soil sand sample in the shear box like that. Use the hooks as well as the guiding screws to handle the sample. That's 3.530 kilograms. Record the value for your calculations. Okay, so to prepare a dense sand sample, fill the shear box using the sand given. Scrape a little off from the top, and using the tamper and the hammer given, compact the soil sample with 25 blows. Now you measure the depth of the sand sample. Now place the cap in the soil sample, wipe off excess sand around the block, and measure the weight again. That's the dense sand sample. So now gently place the shear box in the testing apparatus and make sure it places correctly in the tray, and then tighten these screws. Once you did that, place the loading tray on the soil sample, gently like that. Once you place the hanger on top of the soil shear box, you have to place the 5 kilograms in the loading tray. The loading tray itself weighs about 4 kilograms, so we only place 1 kilogram weight, so the total would be 5 kilograms of normal load on the soil sample. Bring the vertical gauge and back and place it on top of the loading gauge here, and turn the dial and make sure the first reading is set to 0. This is your horizontal displacement gauge, and make sure that is also set to 0. And this is the proving ring. You have to change that to 0 as well. For this proving ring, we have a proving ring reading. You multiply the proving ring reading with that value so that you would get the force acting on the box. At this stage, we remove these screws with the red dot on it. Okay, so this proving ring is proving number 47, and for each proving number we have a calibration number, the newtons per division. So proving number 47, the number of newtons per division is 2.344. You multiply this value by the proving ring reading, and it will give you the shear force of the soil at that particular displacement. Okay, now once everything is set up, we are going to take down the readings in data sheet number 10. There should be 3 students. One should be reading the vertical displacement gauge and tell other 2 students when to take down the readings, and one of the students can take down the proving ring reading, and the other student take down the vertical displacement reading. So once everything is set up, you just make sure the power is on and switch on the machine. Okay, here we go. Yes, just make sure. Now okay, so once you finish taking down the readings, switch off the machine, disengage the clutch, and remove the vertical gauge away from the loading hanger, and remove this piece of weight slowly. Put the loading ring back where it's placed, and then bring back the shear box to the original location. And then tighten the red screws back again. That way you wouldn't spill any soil into the apparatus. So once you conducted the shear test for all 6 samples, that's 3 loose sand samples and 3 dense sand samples, you can fill out the data sheet number 10, and from those data you can fill out the data sheet number 11. You have to fill both the data sheets before you leave the practical. I'll show you how to do a quick calculation to calculate the shear force. So considering the sample 1, the shear force is the force applied by the proving ring divided by the area of the shear box. So that's proving ring reading multiplied by the calibration constant, and that divided by the area of the shear box. So this would be, assuming that we are going to take down the reading for horizontal displacement of 1.00 millimeters. The proving ring reading we've got is 11, and this is multiplied by the calibration constant, that's 2.344 newtons, and this is divided by the area of the shear box, that's 60 by 60 millimeters square, and the value is roughly 7.16 kPa. That's the shear stress at that particular horizontal displacement. So the normal stress, that's the normal load divided by the shear the area of the shear box, that's 5 kilograms divided by 60 by 60 millimeters squared, and this is 13.6 kilopascal. You have to fill out both the tables using these equations, and how to do the reporting as well as the assessment criteria is given in the lab report. For the information, please refer to your lecture notes. Thank you.